We're going to continue to work on systems, and we're going to take a look at the substitution method for solving a system today. If I had the problem that you see on the screen, y equals 2x plus 3, and asked you to solve when x equals 2, most of us would be able to approach this problem very easily because we've been doing this for a little while. You would go ahead and plug in your value of 2 in the x spot. So if x is equal to 2, I am going to plug it in for x. So now I would have y equals 2 times 2 plus 3. So instead of writing my x, I now have 2. 2 times 2 is 4, and 4 plus 3 gives us 7. So we've been doing this for a couple years now. And what we want to do now is take that same thought process and we want to expand it. We're going to apply this to systems. So with systems, remember that is a set of 2 or more equations with the same variable. Here's the first example. I have x equals y minus 3, 10x plus 6y equals 2. If we take a look at this problem, hopefully you notice right away that in one of them I have a variable that is isolated, similar to what we had when we said x is 2. Here, instead of having it set equal to a constant, I'm going to have an expression. So I've got x is equal to y minus 3. So we want to circle the expression and the variable we can substitute. So in here, x is y minus 3. What I will do is in my second equation, I've got to use both my equations. In my second equation, I will plug that expression in for my my x value. The purpose of doing this is I remove one of the variables which allows me to solve. All right, well here's another one. Y equals 5x minus 9, x minus y equals 5. So again, in this I have a variable that's already isolated. Sometimes we will not be that nice and you will have to isolate one. So in this I've got y equals, I've got y isolated. So I am going to take this expression and I am going to plug it in to the y spot of my second equation. We're going to take this problem and we are going to work through the steps right now. So step 1 is what we just did. Okay, we just did step 1. It says to identify the expression that you can plug into the variable. So y equals 5x minus 9, x minus y equals 5. So we're going to be taking 5x minus 9 and plugging it into our y spot. All right, step 2 says substitute the expression in for the variable in the other equation. One of the things we have to understand when we're solving a system, no matter what method, we've covered graphing, we're looking at substitution now, and we will get to elimination. It does not matter which method I am using. I have to understand I have to use both equations during the process. Okay, because we know a solution to a system is a point that works for both equations. So I'm going to go ahead and I am going to plug it in. So I have x minus. Instead of writing y, I am going to write the expression that y is equal to. So minus parentheses 5x minus 9 equals 5. I want you to use parentheses when you are substituting that expression in. So now that I have substituted in, what you should notice is I only have x's. I no longer have y's. This becomes solving an equation which we have been working on. All right, so I have x minus, parentheses, 5x minus 9. Think about that saying that I've been using to help you remember your process. Don't call me after midnight. I start by distributing. Don't get caught. Sometimes students are like, well, I don't have a number to distribute. Yes, you do. We're too lazy to write it, though. There is a -1 there. Okay, this is a very common error that gets students with signs when it comes to distribution. So I have x, -1 times 5x becomes -5x. -1 times -9 becomes +9 is equal to 5. All right, don't call. Call is combine like terms. So if we look at this, x and -5x are my like terms on the same side of the equal sign. So I'm going to combine them. X minus 5x gives me -4x. Plus 9 equals 5. Now I'm going to move my constant. All right, so we do inverse operations. We subtract 9. We're going to pop it on up here. So I have -4x equals -4. All right, almost done. I now need to separate that leading coefficient from that variable. Remember, a number smack dab next to a variable is multiplication. So my inverse is division. So the value of x equals 1. All right, that's my first part done. What I need to do now, as step 4 says, substitute your solution into one of the two original equations in order to solve for the other variable. It looks very much like what I just did on the back of the paper when we started to talk about substitution. If x is equal to 1, I'm going to plug it in and solve for y. So I have two choices of equations. Y equals 5x minus 9. And my second equation we had was x minus y equals 5. You only have to choose one. It doesn't matter which one you choose. However, one is usually easier than the other. All right, and it also comes down to personal preference. I'll do both just so you can see that it does not, in fact, change your answer. So y equals 5. Instead of x, I'm going to be putting that 1 in. Well, 5 times 1 is 5. 5 minus 9 is -4. All right, let's look at the second one. Instead of x, I'm going to write 1. So I have 1 minus y equals 5. Subtract 1 from each side. I have -y equals 4. We divide each side by -1 to get y is equal to -4. So as you can see, it does not in fact matter which one you plug into, you'll end up with the same y value. Step 5 says to write my solution as an ordered pair. Very similar to what I said when we did graphing. Okay, you do all this beautiful work, make sure you finish it, and write these two answers in your proper form. Okay, a coordinate pair is always, okay, x, y. So I'm going to go ahead and say the solution to this problem is 1, -4. All right, great thing, as I said, with systems is I can check myself. I don't have to have any of this guessing work where I think I aced my test and Mrs. Kabibbo grades it and all of a sudden I failed. All right, you're going to know if you did it correctly right away. When we check, just as we did with graphing, we have to check both equations. For a solution to work for a system, it has to work in both equations, not one or the other. So I have y equals 5x minus 9, and I have x minus y equals 5. It is good to check yourself because you will catch silly math errors. Okay? You guys sometimes get annoyed at yourself. I'll be like, you copied this number down wrong. You dropped your negative. You added wrong. So this is really going to troubleshoot for you. My y is negative 4. My x value I got as 1. And I have minus 9 at the end. So let's go do the math. 5 times 1 is 5. 5 minus 9 is negative 4. Works on the first one. Let's check the second one. My x is 1 minus negative 4 equals 5. I don't like double signs. Remember, minus and negative is a plus. So 1 plus 4 equals 5, and 5 equals 5. So we know we did this problem correctly. So you have some practice to do on your own. Okay, this is something that you need to practice. So please go ahead and work on your solving systems using substitution, and I will see you in class tomorrow.